If your SQL queries feel randomly slow, they're not. They're following a chain reaction. And once you see it, you can control it. In this video, I'm breaking down exactly how to turn unpredictable query performance into something you can engineer on demand. Fast queries aren't luck. They're alignment. 3 things have to click: predicates, row estimates, and indexes. Most people treat these like separate tuning tricks. That's the trap. They're not separate, they're a pipeline. And once you see that pipeline in motion, you stop guessing and you start predicting performance before you ever hit execute. But before we go any further, you need to see this. I built a SQL Server demo database so you can follow along and actually watch the optimizer think. Because this doesn't click until you see SQL Server change its mind in real time. With this setup, you can flip a predicate and watch the plan instantly change, see table scans turn into index seeks, watch join order reshuffle based on selectivity, and compare plans side by side like a performance lab. Pause here. Grab the repo linked in the description, spin it up. Because what's coming next? You're not just learning theory, you're watching the entire performance pipeline in motion. Every single query you run follows the exact same path. First, what do you actually want? That's your predicates. Then, how much data are we talking about? That's the estimate. And finally, what's the fastest way to grab it? That's your indexes doing the heavy lifting. And each step feeds the next. This is where everything starts. Not joins, not indexes, predicates. Because the first question SQL Server asks is simple. Can I seek or do I have to scan? That one decision changes everything. Let's start with a mistake that looks harmless but kills performance. This query works. It returns data. Nothing seems wrong. But under the hood, SQL Server gives up before it even begins and does the most expensive thing it possibly can. It scans the entire table. That's fine for 1,000 rows. At 10 million, you've just created an I/O problem. Because SQL Server has to scan every row in every table in a query when no filter exists. And with more complex queries containing multiple joins on multiple tables, that is a lot of data. Now, watch this. We're not rewriting the query. We're not tuning anything complex. We're adding one line, a filter, requesting a single customer. And that single line forces SQL Server to go from brute force to laser-focused precision. Now, everything flips. A table scan turns into a clustered index seek. A full read is direct navigation via the B tree. And high I/O is minimal page access. Same query, completely different workload. Now here's where things get dangerous. Even with a perfect predicate, SQL Server still has to guess. How many rows is this? And that guess drives join order, execution strategy, and memory allocation. Get it right, everything flows. Get it wrong, the entire plan warps around a bad assumption. And that's how simple queries become expensive ones. SQL Server chooses a path through your data, and that path is join order. First, the optimizer picks a starting table, and if it starts small, everything downstream gets cheaper. But if it starts big, you've already lost efficiency before the first join finishes. And join order isn't logical, it's mathematical. It's driven by cardinality estimates. How many rows will this produce? Because that number determines what gets joined next, what gets delayed, and what gets avoided entirely. Next, the optimizer is aggressive. It looks for highly selective filters and pushes them as early as possible. Why? Because every row eliminated early is a row that never gets joined, gets sorted, gets processed again. And that's how you reduce costs before it compounds. Join order doesn't just affect when things happen, it determines what's even possible. Because different join algorithms need different conditions. Small input, you get nested loops. Large unsorted data is a hash join. And pre-sorted data, merge join. Wrong order, you force the optimizer into a worse strategy. The right order, you unlock the cheapest path possible. The real goal is not joining tables. It's shrinking data early, aggressively, repeatedly. The best plans avoid processing data at all. Join order is the control system behind your entire execution plan. At first glance, this query looks harmless. Just a simple join between sales customer and sales order. A couple of filters, nothing crazy, right? But here's where things get interesting. There are 0 indexes supporting anything in that where clause. Not on customer city, not on order total amount, not even on order date. So what does that mean? It means SQL Server has no shortcut, no fast lane, no clever seek. It's stuck doing the only thing it can do, scanning everything. Let's break down what's actually happening behind the scenes. SQL Server scans the entire customer table to find people in Houston. Then it scans the entire order table to find qualifying orders. Then it joins those massive result sets together. And if your tables are big, that's a performance disaster waiting to happen. SQL Server has to decide, which table should I touch first? With no covering indexes, both tables are equally blind. So the optimizer leans heavily on cardinality estimation. It asks, how many customers live in Houston? How many orders are over $1,000? How many orders were placed in the last 30 days? And most importantly, how many rows will survive after these filters? If SQL Server thinks Houston has only a handful of customers, it will start with sales customer. But if it thinks sales order has very few recent high value orders, it will start with that. Join order is 100% driven by estimated row counts. And here's the kicker. With no indexes, SQL Server has no histogram, no statistics on filter columns, and no distribution data. So it guesses. SQL Server isn't rolling the dice when it picks a join. It's building a strategy. Sometimes it goes full brute force. It spins up a hash table and powers through huge, messy, unsorted data. Other times it's smooth, a merge join, gliding through perfectly ordered inputs like it barely has to try. And when one side is tiny, it snaps into nested loops, rapid fire lookups, one row at a time, insanely fast. All right, so now you understand the 3 join strategies. Now let's bring it back to this query. No supporting indexes, multiple filters, potentially large tables. You usually get this, a hash join, which is basically, I don't trust the data, so I'm brute forcing this. It builds a hash table in memory, it scans everything, and it matches rows the hard way. It works, but it's expensive. And it's usually a symptom, not a solution. We're going to take a detour. But stay with me, because this is another strategy. We've got this query. At first glance, pretty standard join, but that order by order ID, that's the trigger. If both inputs are sorted on order ID, SQL Server doesn't hash, it doesn't loop, it merges. And this is where the merge join shines. Think of it like two perfectly sorted decks of cards. One deck orders, another deck order items. SQL Server places these side by side and just walks through them in sync. Just a smooth, linear pass. It's insanely efficient. Minimal memory usage, no hashing overhead, no repeated scans, just pure sequential processing. And nested loops, that's the one we're holding back, because when it shows up, it means everything is aligned. We'll come back to that. Now let's talk about what really hurts performance. Memory. Think of your system like a power grid. Most queries, no problem. Then the heavy hitters show up. Big joins, large sorts, complex workloads. They don't just use memory, they reserve it up front. And SQL Server decides that before the query even starts. That's your memory grant. So if it thinks 500 rows, but gets 50,000, it spills to TempDB, and performance goes from fast to what is happening. That's your rolling blackout. Not everything crashes, but everything slows. Now we fix it. But let's be clear. Indexes are not magic. They're enablers. They don't fix bad queries, they amplify good ones. When everything lines up with clean predicates, accurate estimates, and smart indexes, that's when SQL Server stops guessing and starts navigating directly to your data. So here's what just happened. We gave SQL Server a query with no support. It guessed, it scanned, it hashed, it over-allocated memory, and we paid for it. Now we flip the script. We don't let SQL Server struggle. We guide it. We'll introduce two covering indexes. These indexes don't just help, they remove uncertainty. Everything the query needs, already in the index. No lookups, no detours, no wasted work. The data isn't chaotic anymore, it's controlled. Filtered early, pre-aligned, cheap to get. So the optimizer pauses and recalculates. I don't need to brute force this. And just like that, it switches gears. Instead, it goes with precision. Seek, match, repeat. Row by row, laser focused, almost no overhead. This is what we've been building towards the entire time, because nested loops aren't just another join strategy. It's the ideal path when your query is engineered correctly. And right here, everything finally lines up. Let's zoom in. On customer, we index city so SQL Server can seek directly to Houston. We also include a customer ID and name, so no extra lookups are needed. On order, we index customer ID, making the join fast and efficient. We included everything else, so the query is fully covered. No more guessing, no more scanning. SQL Server now has a clear, efficient path to the data. And the results? Seeks instead of scans, lightweight joins instead of heavy ones, and TempDB finally gets a break. Same query, different outcome. That's the power of giving the optimizer exactly what it needs. Here's the big takeaway. SQL performance isn't random. It's a pipeline. Good predicates enable seeks. Good seeks improve estimates. And good estimates unlock better plans. Break the chain anywhere and performance collapses. Don't just write queries that return data. Write queries that help SQL Server find data efficiently. Because once you see the pipeline, you stop reacting to slow queries and start predicting performance before they even run. If this shifted how you think about SQL Server performance, don't let it slip. Don't just watch it, Lock it in. Because what you just saw, that's not advanced tuning. That's the foundation everything else depends on. So, if you're serious about writing faster, predictable queries, hit like, subscribe, turn on notifications, and keep building the skills that let you engineer performance on demand. Thanks for watching and taking another step in transforming your curiosity into expertise.